I would like for you guys to put your phones and things away. Some of you didn't do as amazing as you had hoped on the test, but we still have one more test for this marking period. So the next test you guys can still do amazing on. A lot of the next quiz is over the stuff we did last time. So that's good for some of you because maybe you found that that was pretty easy. I feel like today's lesson, majority of it is really simple. And so this is another part of the next quiz that you should do really well on. Thank you. Thank you. Thank you. Will you staple it to the back, please? Thank you. Victor, can you remind us about the bathroom pass? Yeah, write your name and the time you leave if you need to go to the bathroom. So if you take the pass, no big deal, just write your name and the time. A lot of the stuff we're doing today, I'm actually going to have volunteers to kind of go up there because I feel like some of it is so simple. I feel like you guys can get it. So today we're going to talk about inverse relations and inverse functions. So inverse relations, we simply switch X and Y. We simply switch X and Y. So this is our relation. A relation is just a list of numbers. And we simply switch X and Y. So I'm going to write my inverse relation. And I'm going to switch X and Y. Everybody see what I did there? Oh, it's just a bracket. That's pretty easy, right? Can we do that? Switch X and Y? That's an inverse. That's like it. Switching X and Y is like the takeaway message for inverses altogether. You switch X and Y. So this says graphs of inverses. Well, graphs of inverses reflect over the line y is equal to x because you just switch x and y. So if you just switch x and y, they're going to reflect over that line. So what we're going to do is we are going to jot down, we're going to make a table. So we've got a list of points in problem number 1, but let's look at it like a table because I feel like that's kind of easier for us. So I'm going to take my points from number 1 and I'm going to write them down as a table. So I have my first, I'm going to have my X and my Y for my first one. Did I write those down correctly? Because I can't see them. I kind of had to do it by memory. Y'all have to tell me I'm not looking at the worksheet. Are those correct? Okay. So now I'm going to make a table for my inverse. And so what does it mean to be an inverse again? What do you do? Anybody else know? What do we do? Switch X and Y. So I'm going to have, what's another name for Y? It is for the range, but we write it, when we write it in function notation, what is it? F of X, very good. So remember, another name for Y is F of X. So in my first table, it is also F of X because there's a symbol for inverse. So when I make my inverse table, I can have X. And then the symbol for inverse kind of looks like F of X. It's just got a little -1 right there. That's kind of weird, but that's the symbol or the notation for inverse. That's how we can tell the difference in our table and then the table of our inverse. So all I'm going to do again is just switch the X and Y. So you guys have been doing dot to dot pictures until you want to puke. You're going to do one more. Well, you're going to do a lot more, but we're going to do one kind of here. So I need a volunteer to plot these points. It says plot and then connect the points. So I need a volunteer to just go up and plot these points and connect them. It's pretty easy. Makes a pretty simple picture. The first table. And I also want you to take your homework paper and stamp it. So connect the dots as you go. We're going to make one figure. Awesome. Good job. I didn't say that. So I need another volunteer to use a different color and plot the points, connect the dots for my inverse. And I do it. Great job, friends. So the first one, we plot those points, we connect the dots. Y'all love doing that. And then we've got our second graph. What do you notice about these graphs? They're the same, that's for sure. Yeah, they're the same. I'm gonna fix my line. My line's kind of ugly. Her line is good. Do you see how one is just turned on its side? So this part right here where it says that it's reflected over Y, I'm gonna sketch that line on here. So the graph of Y is equal to X. Is that line right there. Do you see how if I took my graph and I folded it on in half, it would match up? They're like mirror images of each other. They reflect. So anytime you make a graph, it is always going to reflect over that line right there. Y is equal to X, like the diagonal line through your graph. If you do it correctly, it reflects. So let's practice. You have 3 graphs right here. We're going to practice making inverse graphs. How do we do that? Those of you that want to ace your quiz, you're going to take the time. You're going to plot some points. You're going to make a little table of what you're given, and you're going to make a table of the inverse and plot those. Just eyeballing it and trying to make a new graph, you're going to make mistakes. So on the first graph, just pick some points. It doesn't really matter where. Just pick a couple points. I would say at least 4 or so points will get you a good graph. The middle one, we've got 2 endpoints, but we need a little bit more than that. We could use that one and that one, and that one. That will help. And then the last graph, we've already got some points. And since there's an arrow on this one, if on a quiz, I asked you to draw this one, I would expect that one end of it is a dot and one end of it is an arrow. But you can still use this point right here to help you. And then once you make that point, make sure you make it an arrow. So I'm going to let you guys try. You guys are going to make a table of each of them. It's going to take you a few minutes. You're going to make a table for each of them, and you're going to try and sketch that out. Again, it will be very hard to do if you do not make yourself a table. So make yourself a table. You could start with -5, 2. And you should make your graphs and then see if your friend gets the same things. Do what? Okay, good. Yes, yes, yes. She said, my friend wanted me to turn this in, but I don't really know where to put it. If the first one is making you crazy, move on to the second one. Don't sit there and stare at something making you crazy. Go look at the next. Go look at the next. Let's see. Thank you. Hey, don't wait on me to do these. I want you guys to try them. Try all three of them. You be nice. That's what my girls try and tell me too. Oh, that's just how we show each other love. No, don't be mean to each other. If you feel super brave, you can go put one of them up there. And make sure you stamp your paper, stamp your homework paper. Don't stamp your notes. That doesn't help. That looks good.
But like, do you have to do these?
What?
The bottom one? Like, okay.
Mhm.
Oh. and the
You did
tab.
fine. Oh, what do you mean? What are you asking?
Like if I How did this work? Because I was confused on the view.
For this one, so it's -1, -5, so, so it'd be -5. And then -1. So I think these two endpoints are just one off. See how they're
But like,
two away?
you just like swap it and
Yeah.
then you just.
Yeah, that's it.
Can I try it?
Yeah, you should. And make sure you stamp your homework paper. So write down the two endpoints. We've got one that's at -1, -5. Okay, now flip it. So that's gonna be at -5, -1. Yep. Mhm. So everybody should be trying these graphs. You want to do it on the board for us?
I'm getting extra. And that's right over. Okay, forward. Huh? Okay, forward. Forward.
Good job. Make sure when you go out there, you stamp your homework paper. What? The homework paper? Yep. So the first graph. Were you guys stressing out with the first graph? It was kind of weird, right? But if you reflect it over that line, I'm gonna go to mine, which are, y'all did great. Y'all matched up my graphs perfectly. But if you reflect over this line, that means that everything on that side is gonna come to this side. So it just so happens that when you have a line and it looks like that, it reflects over itself. Doesn't really change. For this one, good job. It's going to still reflect over that line. You don't have to draw the line. You can mentally look at the line, but it's going to reflect over that line. And it does. Good job. The last one kind of weird too. but it also reflects over that line. I am telling you that you guys are going to make mistakes if you don't make a table. On your quiz, I give you a question and I give you a graph. It's not like the first graph. I wouldn't make you crazy like that. It's more like the third graph. And you have two tables given to you, and you just need to fill out the table for the graph, fill out the table for the inverse, and plot it. That's it. So inverse functions, you switch X and Y. That is an inverse. No. Mm-mm. The light blue one? No. So how do you think you will do on that quiz question? I hope we do good. So now we have a brain break. And this one is from a student as well. And we haven't done one like this, so again, you can do one about anything. Who can come up with any food places that start with the letter D? Jenny? Huh? No, I think another one. I can't think of much. I can't think of any past that. Oh, Domino's. Dunkin' Donuts. Yeah, I can't think of any other ones either. These are hard for me. Here's another one. Movies that start with the letter K. Oh, Kill Bill. Kill Bill 2. Karate Kid. Yeah, Kazan, that's a good one. Y'all are coming up with different ones in my first period. Oh, Kung Fu Panda, that's a good one. I can't think of any more. K's a hard letter, I feel like. TV shows that start with B. Breaking Bad. Barbies. Barbies in the Dream House. Yep. I feel like there's like Britain's Bake Show. Yeah, I heard Bake Show.
Big show.
Yes, Big Brother is a show. Big Brother is a show. Mhm. I can't think of any other B's. We have another B, fashion brands that start with a B. So this is like clothes, shoes, jewelry. Isn't it there a brand? It's like BEBE. I don't know how you say it. BB.
Oh, yeah.
Oh, Black House White Market.
Yeah.
Mm-hmm.
Yeah, I don't know.
What, Jalen?
Oh, yeah.
Burberry. That's a good one. Okay, we're gonna do a couple more and then we have actually a couple more of these too. Couple more problems. On to the back, inverse functions. How do we find inverse functions? To find inverse functions, so if you have to do a graph, we just switch x and y. If you have a function, it's the same. You switch x and y. So at the very least, to make an inverse graph or inverse function from an equation, you should be able to switch x and y. The second step is to solve for y. And then last, it's not really doing anything. It's just replacing y with the notation for inverse function, which we used on the front. It's the f of x, but there's a little -1. It's like a little exponent. It's a tiny -1. So the symbol is right here. We're going to find the inverse function. This is the notation for inverse of each equation. So in part of question or step 1, it says switch x and y. Well, for the first problem, it's not really y. It's listed as f of x. So it might be helpful if it's listed as f of x. Let's go ahead and rewrite this and let's change that to y. So y equals. Like that. So I just changed the f of x to a y. For the second problem we're going to do, it's already y, so we don't need to do that step. So to start for inverse function, you have to switch x and y. So x and y, I'm going to rewrite the problem, but I'm going to switch their place. So x goes over here. So step 1, switch x and y. So most of my students do okay with the graphs, okay with switching x and y when it's just a table. This is the part where they sometimes struggle. So this is the part where you need to make sure you keep your phone away and you listen. So all we're going to do for step 2 is solve for y. So we're going to try and make it y equals. So we're going to get all this stuff away from y. So if we want to get y by ourselves, what would be our first step? So we need to get rid of the 2/3. We need to get rid of the +2. Which one do we start with? You have to do addition and subtraction first. So I'm adding 2 on that side. I have to subtract 2. From here, there are 2 things happening. So instead of looking at this as a fraction, as a whole, like it has to stay together, this is 2 times y, and this is y divided by 3. We're going to do them bit by bit. So before we can get to the top, we have to get rid of the bottom. So we're dividing by 3. So over here, we will multiply by 3. And when you multiply, you have to multiply everything. And we can leave it like that. We don't have to distribute it in. And my last step is to get y by itself. It's multiplying by 2 right now. So to undo multiply by 2, I have to divide by 2, and I have to divide everything by 2. So did we switch X and Y? Did we solve for Y? So the last step is just to write it with the function notation. So all I'm gonna do is rewrite it. So f of -1 is equal to 3x minus 2 all over 2. If you are doing a quiz or a test and it's a multiple choice question, you can rule out answer choices that don't have inverse operations. Here's what I mean. If we look at what we were given. So what we were given, we have a +2. Inverse of adding is subtracting. So that's an inverse operation. Here I'm multiplying by 2. Well, inverse of multiply is divide. Here I'm dividing by 3. Inverse of divide is multiply. So if you're looking at a multiple choice question, don't pick an answer or mark answers off if they don't have inverse operations for every number. For the next one, we already have y equals, so we're going to switch x and y, solve for y. And I'm going to tell you that my answer, my ending answer, I have a +2, so it's going to have a -2. I'm dividing by 4, so it's going to have a multiply by 4. Those are inverse operations. So first step, though, I've got to switch x and y and rewrite it. What do I have to do first to try and get y by itself? I have to get rid of the divide by 4. So inverse of divide by 4 would be to multiply by 4. I'm almost done. How do I get y by itself? Did I switch x and y? Did I solve for y? So I'm done. I just need to write it in inverse notation. And again, if this is a multiple choice question, I'm going to make sure that I picked an answer that has inverse operations. I'm dividing by 4. I'm multiplying by 4. This is a +2. It's a -2. So they have to be inverse operations. The next two questions, we're doing the same thing, but we have exponents. So for the first one, we're already written as y equals, so we can go straight to switching x and y. We can switch x and y. Who knows how to undo something to the 6th power? No, we want to get rid of it. If you distribute it, then you're adding something to the y. We don't want y to the 6th power. So if I have something and it's to the 2nd power, does anybody know the inverse operation of squaring something? Square root. Well, what if I have something to the sixth power? I do a sixth root. That's weird, right? So I'm going to get rid of to the sixth power. And to do that, I'm going to bring it over. And I'm going to do the sixth root. To get rid of something to the sixth power, I'm going to bring it over. And I'm going to do the sixth root. So now I will rewrite it. I've got the sixth root of x. I am almost done. What's my last step? The -4 cannot go underneath the square root because it's coming after we did the square root. So we switched x and y and we solved for y. What's my last step? Inverse notation? And again, if I'm taking a multiple choice test and I'm looking at this and I'm trying to find which one is my inverse, I know that it's going to have inverse operations. I am to the sixth power, so I have to have a sixth root. I'm adding 4, so I have to be subtracting 4. The last one, I can't just switch x and y because I don't have a y. So I'm going to have to rewrite it first. So what do you think that we do? Oh, we actually have to switch x and y first. We can't even start. We'll just switch x and y. How do you think that we're going to get rid of the fifth root? To the power of 5. We're going to take the root over and we're going to put this to the power of 5. That's how we undo the fifth root. One last step. Yep. Am I done? Inverse notation. I'm going to add something to this question technically because we just took the sixth root. Anytime you take an even number root, you really need to do plus or minus. So I'm just going to put a little plus and minus. So because it's an even root, add plus and minus to that question. So when you take an even root, we're going to add plus and minus. So inverse functions, you switch X and Y, solve for Y. Singers that start with the letter J.
Justin Timberlake.
Yep, y'all are good. Janet Jackson. Jessie J. Justin Bieber. Yes. Jay-Z. John Lennon. Any others singers that start with the letter J? This is a lot easier than some of the others we've done. Uh-huh. Next one, movies that start with the letter T. Titanic. Ted. Terminator. Transformers. Top Gun. Tremors. Tangled. Toy Story. I think there was a movie called Twister. Tangled. Twilight, yeah. Tinkerbell. Transformers.
I don't know. I thought it was
Maybe. I can't think of any more. Fruits or vegetables that start with the letter Z. Is that a fruit or a vegetable? It is a fruit, friends. Zucchini is a fruit. Fruits have seeds. Really? Huh? Anything with seeds has fruit, is a fruit. Strawberries are interesting ones because they have fruits on the outside, or they have seeds on the outside. These are the seeds. Banana has little black seeds. Avocado is a fruit. It's got a big seed. No. Zucchini is the only one I know. There's actually like a zebra eggplant or something like that, but who knows that? Yeah, somebody said that in my last class. I misspelled vegetable. I had to fix it. We are almost done, but we got to talk about one last thing. So we are going to prove whether or not functions are inverses. So I encourage you to put your phones back away because we are not done. To prove if two functions are inverses, you must be able to show, and what's this new symbol? This is a new symbol. We learned it last time. Of, so this is f of g of x, and we have to prove that that is equal to x, and that g of f of x is equal to x. Remember that that's the of symbol and it means composition. So that means if you take one function and you put it in the other, it simplifies to x. If you take the other function and put it to the other one, it also needs to simplify to equal x. This is a quiz question. This is a quiz question, and I ask you that. If two functions are inverses, which of the following is true? And it's a multiple choice question. There's 4 answers. The answer choice that's correct is showing that f of g of x is equal to x and g of f of x is equal to x. That's a tongue twister. So let's do that. First thing that we can do is we can do f of g of x. That means that we're going to write the f function and we're going to leave a space where we see x. So I just wrote the f function and I left a space where I see x. And in that space, I'm going to put g of x. So now I'm going to try and simplify it. If I can simplify it and it turns into x, then I'm off to the right start for proving that they're inverses. And keep in mind, not everything is an inverse, so they don't always work. So the first thing that I would do to simplify this inside, I have to do PEMDAS, so I would have to get rid of parentheses. So I would have to multiply in 4. What happens if you multiply by 4 and then you divide by 4? What happens if I do 4 times 3? What's 4 times 3? 12. And then what's 12 divided by 4? 3. So multiplying by 4 and then dividing by 4, they undo each other. Oh, there's a 3. From here, do you see anything else we can do to simplify it? Not really. I'm feeling like these might not be inverses of each other. Well, I'm going to go back and I'm going to look at the 2 problems. Well, they both have a 3 and they both have a 4. I mean, that is good. Here I'm square rooting stuff and then I'm squaring stuff. Well, those are inverse operations. Here I'm multiplying by 4 and here I'm dividing by 4. That's an inverse operation. Here I'm subtracting 3. But here I'm like multiplying by 3. Is that an inverse operation? No. So I can stop there. They're not inverses. It does not work. That's not going to simplify to x. That does not equal x. Now I'm going to tell you that if you get it to where it doesn't equal x, you might want to just double check and make sure that the other one doesn't and that you just didn't overlook something. So we can go ahead and also just double check to make sure that if we do it this way, that it doesn't work. So this would be me writing the g function. And where I see the x, I'm going to put in the f function. And if I start to simplify that one, I can do some stuff. So I see that I'm squaring a square root. So squaring a square root undoes that. Well, I could also, if I distributed this in, I'm gonna multiply by 4 and divide by 4, so that 4 will definitely reduce. But then it's 3/4 of 3, so that's 3 times -3, so -9 over 4. At this point, like, that does not equal x. So we can say these are not inverses. They are not inverses of each other. So if I ask you to prove that they're not inverses, this is what I'm asking you to do. Show me that they don't equal x. For the second one, I can double check operations. I've got something to the 3rd power and I'm cube rooting. I'm subtracting 3, I'm adding 3. I'm dividing by 2, I'm multiplying by 2. Pretty good chance that these are going to be inverses. So let's prove it. Let's prove that they're inverses. So first I'm going to plug f of g of x. You could do it in the opposite order. It doesn't really matter. So if I do this, I'm going to write the f function. And where I see x, I'm going to leave myself a space. Oops, it's not squared. It is cubed. And inside my space, I'm going to write the g of x function. PEMDAS tells me that I've got to work with those parentheses first. And inside the parentheses, I am cubing and cube rooting. Those are inverses, so they undo each other. Okay, so now I've still got parentheses. I need to multiply in the 1/2. So I can multiply in this 1/2. What is half of 2? 1. Do you have to write the 1? No, not really. So then I have x plus 3 minus 3. Guess what? That equals x. But to be inverses, they both have to equal x. So I've also got to do g of f of x. So I've got to write my g function. And where I see the x, I got to leave myself space. Okay, so I've got to work inside my cube root. So first thing I have to do is multiply in the 2 to, oh, I put that in the wrong spot. I have to multiply in the 2 to this part and the 2 to this part. What's 2 times 3? Okay, I've got to keep multiplying in that 2. So I've got 2 times 1/2 and then 2 times -3. So what is half of 2 again? Yep. Do I have to write it? So I get x to the third, and 2 times -3 is -6. What's -6 plus 6? So that turns into the cube root of x cubed. These cancel each other out because they're inverses, and you're left with just x. So anytime that you can plug one into the other and vice versa, you can prove that they are inverses. So on a quiz, you would have to show me both. Yes, sir. It's 2 times 1/2. So it's like 2 times 1 divided by 2. Well, 2 times 1/2 is 1. So this turns into a 1 right there. That is it. What should you be doing? You should be working on your homework.